Okay, we're going to skip D here for a minute, reporting probabilities in APA, and we're going to actually move on to the final homework data set. Now notice with this particular data set, I changed my numbers around a little bit, right? The mean for the pre was 1, 4, and 7, so the mean for the pre is still 4. But now, what's the mean for the post, Emily? Got a 2, 6, and 10, so what's the middle number for my simple example? 2, 6,
2, 6, and 10.
So it's
5.
One more.
6.
6. So what does that do to the data set from the previous example? Before, what was it on page 1? On page 1, or the one we just covered, somewhere in there, it was 4 and 9, wasn't it? So the post was a 9 before, right? The mean for the post. Drew, what do you think happens now that after the Taussman-Asma program, the mean was 6? Is that good news or bad news?
Wait, what was it before?
So in the before situation, the mean on the post test was a 9, and now the mean is a 6.
So it's bad news. Right?
That's bad news. My treatment effect is gone down. My program isn't as effective. Before, the treatment effect was 5. Now the treatment effect is 2. So my program isn't as good. So the treatment effect now is 2 on the new screen. Yep, that's a 2, Emily. The treatment effect is now 2. It does say mean, but it's actually mean difference. So the mean difference is now 2. That's not good news, is it? That means my program isn't as effective. So let's carry it out. Notice the standard error of the mean is still the same. And that's because the dispersion is still the same. It's still 1, 4, and 7. It's spread out in the same way. So the standard error of the mean is still the same, 0.577. So now I get a t-score. And if you look at the screen, and we did this in our SPSS, Emily, what's the t-score now?
3.46.
Yeah, 3.464. Because it's the 2 over the 0.57. So how often, Drew, could we get that t-score of 3.464? How often will that occur due to chance?
7.4% of the time.
7.4% of the time. Not quite significant, is it? It's above 0.05. So it's not statistically significant, right?
Right.
But there's a... So you would have to actually write it out, and if you were to write it out, you would write T, if you want to write it out, T, and then in parentheses it would be what?
2
2 equals
equals
3.464. And then you'd actually have to say P is greater than what? 0.05. And you'd have to say this is non-significant and the program did not work. So non-significant, you can just write NS next to it, M. You'd have to say, the Taussman program didn't work. But let me ask you this. Could I take issue with that? I could. How come I could take issue with that, Drew?
That's marginally significant. I mean,
it's very close. This problem that we have here is it's either a yes or no. That's the problem with significance. We didn't make it. Forget it. Didn't work. But we're very close here. And that's a problem. So what we do, and you may want to write this down, is if you get a result that happens due to chance between 0.051, if you get a result, a P between 0.051 and 0.099, we actually use the term, and Drew, have you heard that term before?
Yeah, last semester. Yeah,
we use the term marginal significance. Marginal significance, which is kind of a gray zone. We're not quite significant, but we're what? We're pretty darn close. So in this way, if you were reporting this in APA style, let me tell you the correct way you would report this. So if you want to write out, you wrote out the P greater than 0.5 before, which is technically correct, but let me tell you how you would write this out. So you would write it out T. If you get a result that's marginally significant, you write T and then in parentheses. What would it be, Emily?
2.
2, because you have 3 people, equals what does it equal? 3.4. Actually, you'd write it all out, 3.464. And now, instead of P greater than 0.5, if you get a marginally significant result, you actually write the exact probability. Emily, what is the exact probability on the screen there?
0.07.
Yeah, you write P equals 0.074. And you would write that this result is marginally significant. And what you would probably do is, if you were me, you'd run more people. 3 people isn't enough. If you ran more people, it would be significant. So this is kind of a statistician's view of kind of maybe. Now, if you get a result where the P says 0.12, you're kind of not in the kind of maybe. Are we good? Okay, we'll stop this one.